Example 13 says a committee of 5 is chosen from 5 mathematicians and 6 economists. How many different committees are possible if the committee must include 2 mathematicians and 3 economists? So this one's a little more difficult. Let's take a look at this one and kind of break it down. So the first thing I need to realize is I need to pick math separate from what I'm going to write as econ. I need to realize that there's 5 total mathematicians, and of the 5 mathematicians, I want 2 of them. This is a committee, so the question is, does order matter on a committee? And the answer is no. Order does not matter. You're either on the committee or you're not. Doesn't matter which position you were picked. So order does not matter. No order. Because there's no order, I know that I'm going to be using combinations, not permutations. So let's go back to that math. There was 5 total mathematicians. Of the 5 mathematicians, I need 2 of them with order not mattering. There were 6 economists. If I look at that, order doesn't matter, and I only wanted 3 of them. So I'm going to do 5, choose 2. I'm going to do 6, choose 3. And the counting principle says multiply those 2 things together. When I multiply those 2 things together and put it into my calculator, I seem to be getting 200 possible choices. So common errors with this problem is a lot of people would have done 11, choose 5. Make sure you don't do 11, choose 5. I know that there are 11 total, and you do want 5 total, but that would be if it didn't matter how many math and how many econs were there. If they just said they needed a 5-person committee, it would have been 11, choose 5. This one, we do need specifically 2 math and 3 econs, so we had to separate it out. Let's look at the next problem and see how that works. It says an IRS auditor randomly chooses 5 tax returns to audit from a stack of 10 tax returns, 4 of which are from corporations and 6 of which are from individuals. And how many different ways can the auditor choose the tax returns if the auditor wants to include 3 corporate and 2 individual returns? So again, we need to break this down into 2 separate things that we're picking. First thing we need to look at is corporate. Second thing we need to look at is individual. We can't group these together because it's very specific in what we want. So let's think about it. He's grabbing tax returns. It doesn't matter if he grabbed you first or grabbed you second. You're being audited. So it's an audit, so we're going to say no order here. If there's no order, I'm going to be using combinations, not permutations. So let's read it again. It said 4 are from corporations, so there's a total of 4. Of those, I need to include 3 of them. And then it says 6 are from individuals. Of those, I need to include 2 of them. Again, order doesn't matter. You're either picked to be audited or you're not. Fundamental counting principle says multiply those 2 numbers together. Take a minute, put that into your calculator. I'm getting a total of 60 different ways that he could choose 3 corporate and 2 individual tax returns. Look at this next part here. I want you to read this paragraph. It talks about the lottery. Lottery is very horrible odds of winning. So, one of the biggest mistakes made when determining lottery is people think order matters, because it matters what number is picked. But mattering what number is picked doesn't matter when that number is picked. Order does not matter with lottery. If I pick the numbers 5, 7, and 10, it doesn't matter if when the balls come up that it was 10, 7, and 5, 10, 5, then 7, 5, 7, then 10. It doesn't matter which order those balls came up in as long as those numbered balls came up. So, order does not matter. In this example that they're talking about, there's 50 numbers to choose from, and they picked 6 of those numbers. Again, order doesn't matter. So that means your probability of winning is 1 out of 15,890,700. Extremely low odds. And this talks about, well, if there's only 15 million answers and the prize is higher than 15 million, why wouldn't you buy every single possible ticket so you can ensure that you would win? The answer is, well, number one, there's not enough time for you to buy all those tickets. Number two, you need to come up with the $15+ million to buy the tickets. And number three, what if someone else won the game? So if someone else wins as well, you split the prize money in half and you're out of luck. So you got to be really, really careful and understand that your probability of winning is extremely low.